Hi, everybody. My name is Richard Abeles and my partner, Aylet Aceves. We welcome to our presentation on the 10 frame model from building number sense in transitional kindergarten through third grade. We selected this model, researched how it's used with students, and reviewed the CSA overview. We'll start by introducing the model, describe how it fits with the CSA phases, and then at the end, we'll do an engagement activity. So let's dive right in. So today we're going to explore the 10 frame as a math model and how it fits in the CSA approach to help young students master the early number concepts. This sets the stage for our overview. The 10 frame is a simple visual tool designed to help young students build a strong foundation in number sense. So we're going to see examples as we go along. This model is especially useful for TK through third grade. They develop early math skills. It's like a visual map for them that shows how numbers fit together in the base 10 system. Now let's get into details of the model. So what is the 10 frame? The 10 frame is a rectangular frame with 2 rows of 5 boxes equaling 10 boxes. These boxes are used to place objects to represent numbers 1 through 10. You can extend it to 20 with double frames, and it's ideal for TK to third grade to build a base 10 understanding. This model is primarily used for teaching early number concepts, including counting, additional, and subtraction within 10. And don't forget, it does extend to 20 with double frames. It also teaches composing and decomposing numbers, place value basics, and number bonds, which are ways to make 10, something we're going to encounter in our activity later on as well. It's not typically used for advanced topics like geometry or fractions beyond the introductory levels, but it can introduce simple fractions like 7 over 10 as a filled frame. So for TK through third grade, it focuses on operations and number relationships rather than all math areas. So here's a quick video to show you in real time how the 10 frame looks, so you can be able to visualize it as we go along through details of the model. So this is the 10 frame, which is laminated, or we can draw ourselves. The laminated ones are best, especially if you're in the classroom, because they're ready to go with the dry erase. And then here are the manipulatives. So double-sided coins, which can be used to fill the card. We're gonna just go through the video quickly so we can see. So you can see how it adds up to 5. And then later on, we're going to split that 5 up into 2 boxes. So the top has 3, the bottom has 2, which can be later on put into an equation. As you can see here, 5 red, 2 yellow. And what would that do if we continue on writing an equation? 5 plus 2 equals 7. So there's a quick overview. So let's continue. Here we address what does the 10 frame do for students and how does it break it down? First, what it does. It builds confidence in math by turning numbers into something tangible and fun, fostering flexible thinking and problem solving. Here is where students develop that stronger number sense, which is crucial for later skills like multi-digit addition or multiplication. It also encourages perseverance as kids experiment with different ways to fill the frame, and it also supports that diverse learner by allowing hands-on interaction before moving to symbols, keeping it fun and tangible. It turns math into play for that TK to third grade engagement. Second, how it breaks it down. The 10 frame breaks numbers into relatable chunks based on 5 and 10. For instance, to show 6, students fill the top row, 5, and add 1 more in the bottom, which highlights it's 1 more than 5. For 9, you see on the second one, they see it's 1 less than 10, which simplifies addition subtraction. So 9 plus 1 equals 10 is easier to visualize. This structure promotes efficient strategies like counting from 5 rather than starting from 1 every time, and scales up for teens using 2 frames for 13 as 110 and 3 ones. As the images show, it turns that confusion into happiness. This overview sets the stage for how the 10 frame fits into the CSA model. So now my partner Aylet will take you through the CSA overview.
Okay, hi guys, my name's Aylet Aceves, and thank you, Richard, for covering the overview of the 10 frame model. So I'll be describing the model at each phase of CSA. So the CSA model stands for concrete, which is hands-on, semi-concrete, more drawing or visuals, and abstract, which is using symbols and thinking, which aligns perfectly with the 10 frame that progresses from physical to visual and finally to pure numbers, breaking down TK to third graders' deep understanding. So, why does this work? So, it builds sensory to symbolic, where students learn step by step as their brains grow. So, let's take a look at the examples. Concrete, the use of real blocks. Semi-concrete is drawings and abstract with equations. For example, 4 plus 5 equals 9. And we'll detail the phase starting with concrete. So in concrete phase C, the 10 frame uses real objects for hands-on exploration. So it feels like play, but also reinforces concepts. So you can see what the model looks like. Students will use a physical 10 frame. This can be a cardstock or plastic frame with 10 slots, and they will place items directly into the boxes to either build or break apart numbers. So for example, to solve 4 plus 3, they start with 4 counters in the frame and then add 3 more, seeing the total fill up to 7. So here are some of the items that can be used. They can use colorful counters, linking cubes, buttons, beans, teddy bears, which you can see there on the slide. So this would be good for TK through first graders. So here are some activities that can be used. Building numbers. So have students fill a card with 7, then discuss how many more to make 10. Also addition and subtraction games like make 10. This is by adding counters to fill the card or even removing items by using maybe like 8 minus 2. Another activity is partner sharing. So this is where students build a number secretly and their partner guesses it by looking at the frame, which promotes communication and subtitling. Now, these activities help TKers through third graders succeed by touching and verifying. So now this transitions to semi-concrete. Now, phase S, semi-concrete, is where students transition from physical objects to now drawings or pictures. So this is like creating their own visuals of the 10 frame. So this representational step bridges concrete and abstract by encouraging the students to draw what they've experienced. So this is what it looks like. For a student representation, I drew a 2 by 5 grid and added colored dots to represent numbers instead of real objects. So for 5 plus 1, they would draw one frame with 5 filled circles and one more in a second frame, then combine to show 6. This phase builds visualization skills without needing physical objects. So they can label the 10 frame with how this shows right here. This shows 6 because 5 plus 1, as you can see on the slide. Now, this phase helps students internalize the structure, making it easier to see math mentally before jumping to equations. Now, our last phase is abstract. So this is where the 10 frame structure leads to symbolic math, which is numbers and operations without visuals. So the model builds to this by repeatedly showing how visuals connect to symbols so students can apply number relationships independently. So this is how it builds. So prior phases show patterns full, which equals 10, leading to mental imagery. Students learn that a full top row is 5 and the whole frame is 10. Now, this foundation makes equations feel logical rather than mysterious. For TKers through third graders, it builds from I see 7 dots, which is concrete, to 7 plus 3 equals 10, being abstract. So this is what math looks like. Equations we solve mentally, taking like 8 plus 2 equals blank. Imagine the 10 frame with 8 dots, 2 empty boxes, means adding 2 fills it up to 10. So 8 plus 2 would equal 10. Or even 13 minus 5 would equal 8. With 2 frames, 10 plus 3, remove 5, back to 10. Then you see 8 remaining. This fluency comes from seeing patterns before. So some activities that can be used are flash recall. So writing from memory. And this is a TK to first example. Writing number sentences from memory. So after flashing a 10 frame image briefly, the student can write what they see, like 9 plus 1 equals 10. With second to third graders, the students create this equation using two 10 tables as shown here. 16 minus 7 equals 9. By third grade, this phase builds mental math and fluency with the 10 frames as a safety net for review if needed. So this wraps up the CSA description on my end. Now Richard will take you through a Make 10 challenge where you get to be hands-on and engage in what we learned today.
Hi, everybody. So our activity we're going to engage in is the concrete phase of the CSA, as it's the most accessible for hands-on learning. This phase is great for TK through third grade and easy to do at home, which is perfect considering we're all at home engaging in this activity. So this is our goal. Show how to use a 10 frame in class using the concrete phase and engage in the activity. So in the 10 frame Make 10 challenge, you're going to grab some household items like pennies, or buttons, pasta pieces, or even drawn circles on papers as counters. So we're going to draw a 10 frame, 2 rows of 5 boxes, as you see here on a piece of paper. Note, you do have access to the slide, so you will be able to use the linked 10 frame as your own, and also the manipulatives, they do move around as well. So your goal is to use your items to fill the frame in different ways to make exactly 10. So like 3 combinations, like 5 plus 5, 7 plus 3, or 4 plus 6. For each, write what it shows. 7 and 3 make 10. This builds addition skills and shows how numbers fit together. It's important to know why we're using this phase. These concrete items make it fun and low pressure, so everyone can participate without advanced skills. So you definitely get to use this activity as a low floor, high ceiling. So now that we had fun getting our at-home item and tested the challenge, let's share our findings. We added a Padlet code, QR code on this slide, so you can scan it, use your phone or device that you're on to access the 10 frame challenge board. After trying the activity, add your results there. So write one combination you made, like 6 plus 4 equals 10 with using pennies, and why it works. Or upload a photo of your filled 10 frame. This will let us see our work in real time as we're doing it and discuss these variations together in our next class. I'll show you an example of the Padlet. So here you can see we drew our own 10 frame and use a pile of pennies, and we even faced them tails and heads so we can see how different. So 6 tails, 4 heads equals 10. 6 and 4 make 10. And then we added Y. So making 10 using pennies, why this works, because 10 frame has 10 boxes in total. Seeing the pennies in the grid shows that 6 is close to 10. So adding 4 more pennies completes it, which helps you understand addition and number bonds. So this was an awesome and is an awesome assignment and model to introduce to your classroom. So going through the CSA empowers young learners to own math concepts. So everyone, thank you for engaging in our 10 frame world. Now let's see our creations on Padlet. Thank you, everybody.